You have probably written very many methods where you check the input parameters to make sure they're valid. And if they're invalid, you'll give the user back a message or you'll prompt them to try the method a second time. And that's great. But now let's move into more sophisticated error handling using Java's error handling methods. We're going to introduce you to something called exceptions and the TryCatch block. I want to begin to define something called risky code. Risky code in Java is code that could result in an error state. For example, what if you were going to open up a file from the file system? That could be a risky operation. You might pass in the file path, and when the program goes to look in that directory, if the file is not there, then your program will be thrown into an error state. Similarly, there's another method you may have used called parsing. There's a method in the integer class called Parse int, and that method can yield an exception. We can tell that by looking at the API, and we can look at the API record for the integer.parseInt method. And as you can see, as part of this API, there's a section at the bottom called throws. And this throws section is going to tell you if this method is risky, if this method can sometimes throw an exception. So in this section of code right here, we're going to invoke the method 3 separate times. We're going to call parseInt and pass it the integer string 123. We're going to call parseInt and pass it ray, which is probably not going to be an integer. And then we're going to pass 13. And we'll see what happens. When this program is run, you'll notice that the first invocation, which prints out 1, 2, 3, works. But then when it tries to parse int for ray, it does not work. In this particular case, this error message, this exception, is thrown. And you get this result. What you get is a number format exception, which is exactly what you were told you would see inside the API. So this is what we ran on the last slide. We just ran the code, and once we hit ray, the parseInt raised an exception, and we had this message show up. What we could do instead, though, is we could work what's happening up on the top. In the top, we have used a TryCatch block, and we've taken our risky code and we've put it inside of a try block. And being inside a try block says, I want to attempt this code, but I'm aware that an exception could happen. If an exception happens in the try block, you would then immediately come down to the catch block. And I'm just catching any exception. We'll talk about how to be more specific later. But anytime an exception is raised and my program is in an error state, I can recover and I can say system.println, I've caught the exception. When we run the code, we run the method the first time with the number 1, 2, 3, and that works, as you can see below. And then we run our next line of code, and that's the line of code that gives us an exception. When that happens, the program immediately goes into an error state and control passes to the catch block. When control passes to the catch block will run, and that's why it printed out this message. Notice that I never go back to the try block. I am finished with the try block. And then resumption of the code would happen right here at this point below the TryCatch block. So again, put risky code in the TryCatch block inside of the try. If an exception were to happen, your program moves into an error state, control passes to the catch block, it tries to catch the exception, do the code inside the catch block, and then the program continues. One thing you might notice, though, with this block of code we just saw, is that while we were able to do 123 and we recovered from ray, we were unable to get to the last line of code. because after array raised an exception, we were out of the catch block and our code was down here someplace. So one thing we can do instead would be to put each individual risky bit of code in its own TryCatch block. And this way, when we work with 123, it'll work. When we work with array, it will not. We'll jump to the catch block, but then we will actually come down to the next try block, and this will work. So the results we see will look something like this. However, this looks very repetitive and is probably not our ultimate solution. How about this solution? In this solution, we take our TryCatch block to parse an integer, and we put it inside of a method called parse int and add. And this method can be called multiple times. Now, as you see above, we have a do-while loop. And in the do-while loop, we continuously ask to parse an int and add it to an array list. And that's what happens here. This way, we don't have 3 separate TryCatch blocks doing the same thing. We've pulled that common code out into a method, and we've called the method multiple times. This is much better design. The last thing for us to explore is an embedded TryCatch block. Here's the same method we saw before. It's the parse int and add method. And in this method, again, as we saw before, we have a try block here, and we have a catch block here. Only this time, it's a little bit different because inside the catch block, we have a second TryCatch block. And that TryCatch block, there's the try, and there's the catch. So how does this work? We're calling this method 3 times in our do-while loop of the other method. And on the first time in, when we try to parse an int, we're dealing with 123. And 123 works fine, and so the try block runs. Then we jump down to the end of the method, and we're done. Our second time in the method, we are now looking again at this call, only now the string that passed in was Ray. And we go, Ray? Well, Ray is not an integer. What we're concerned about here, though, is that perhaps someone is entering hexadecimal numbers. Of course, Ray would not be one. But we do ask the question, and we say, were you entering a hex value? Giving them a second chance to maybe salvage what they tried to type in with Ray. However, they said, no, we're not. And so Ray, as has always happened, is ignored and not added into the array list. The third time in, we come down and we added in a D, as you can see right here. And the D also causes parse int to fail, and so the code comes down to the catch block and into the next try. And here it says D is not an integer, and were you trying to enter a hex value? Here, if I said yes, which I did below right here, then it will try to parse that into a hex character and add that hex number into my array list. So, interesting example, but its primary purpose is to show you that you can have a second TryCatch block inside of a catch. It gives the user a second chance to try to recover. Now, there's no limit to 2. You could have, if you wanted to, you could have another TryCatch block in here, and so on and so on. But at some point, you're nesting so many TryCatch blocks that it doesn't make good design sense. And this covers part 1, our introduction to exceptions and TryCatch blocks.